Okay, sorry for the AV difficulties. Well, welcome everyone to RSS 2022. My name is Chris Hauser, and I'm the program chair. It's thrilling to see you all here in New York City in person, and this is my personal favorite robotics conference. No offense to ICRA, of course. I'm excited to see so many familiar faces in the room, and some of you are actually new here. So I want to just check with a show of hands, how many of you, for how many of you is this your first RSS conference? Wow, okay, that is fantastic. I'm very excited to see so many new people here. This is a great conference, and I'd really like to show how fantastic this conference really is. We have okay, one other question. How many of you, for how many of you is this your first conference post-COVID? Wow, okay, not a lot of ICRA attendees here. Okay, great. Well, so you're in for a treat because we have a huge number of exciting events for you this week, and I would like to, well, I wish I had some AV here. All right, so let's see, let's go ahead and...
We come to this place
so
for magic. We come to a conference to laugh, to cry, to care, because we need that, all of us. That indescribable feeling we get when the lights begin to dim and we learn something we've never known before, not just informed, but somehow reborn, together. Dazzling figures on a huge PowerPoint screen, proofs that I can feel. Somehow, heartbreak feels good in a place like this. Our academic heroes feel like the best part of us, and papers feel perfect and powerful. Because here, they are. RSS 2022, we make robotics better.
Thank you for that. If you don't get the joke, just Google Nicole Kidman AMC Theaters, and you'll hopefully get it. All right, so I want to say a few things about RSS. Sticking with the RSS tradition, we have a single-track conference, which is a fantastic way for all of you to see the best and the newest in robotics. We get a broad cross-section of robotics researchers, put them in the same room, and we share a common experience intellectually, socially, and culturally. With the conversations we have here, we get to collectively define what our field is, and we get to redefine where it's going. That's the feeling of collective culture that we've been missing so much during the pandemic. So let's see, let's go ahead and, oh, I got the clicker here. All right, I have a couple of bits of information for you before we start. Just for those of you who haven't seen this yet, our public information for those of you who are attending is up here at this attending site. Our Wi-Fi here is just the Columbia Public Wi-Fi network. No need to log into anything to log in, so very easy to get set up. For those of you who are watching online, we do have a Zoom session as well as a YouTube session that's broadcast for free. For those of you who are virtual participants watching out there, please log in to Feedloop, which is given by this site. You're given the stream to the webinar as well as the ability to ask questions and also type things in the chat. Please use the Q&A for questions. If you, during the Q&A sessions, we will be monitoring the Q&A in Feedloop on the Zoom room, and we will then relay those questions to the speakers up here. So for those of you who are online, in order to get all of the content, please log in through the channel as shown here on the slide. Some of you have already gone to workshops. Some of you will be sticking around for workshops. Oh, sorry, that's not this slide here. Okay, one other thing that I'll say, technical issue, is that oftentimes watching a Zoom session in the browser is not great. So if you do have some problems kind of logging on, click on the little bar at the bottom of the stream window and then open things up in your own Zoom browser. For those of you who require captions, we do have live captions available on the Zoom stream. We also do have a URL. If you click on this attending page, the URLs for each individual session are given, and you'll get a live transcript of the transcription going on now. All right, COVID policies. So for those of you who have not had COVID yet, congratulations. I did get COVID after ICRA, and many of my colleagues have as well. Even though if you're not worried about getting seriously sick, being sick for 1 or 2 weeks is no fun. My department chair is currently sick from COVID after catching it from ICRA. So please keep your masks on. This is Columbia University policy, and if you need a mask, we have them at the registration desk. If you are eating, drinking, or speaking, you may go ahead and remove those masks if you prefer. If you need to get help, whether it's directions or with your talk or your poster, you can either go and find a volunteer. They're in the white I Love RSS shirts. I guess that's I Robot RSS shirts. Or you can email our local arrangements chair, Matej Chakarli, the hardest working man in the room right now, and he'll respond quickly. He's not checking his email though right now, I see. So if there's any urgent issues involving safety, we have the Columbia helpline up here. You should call them on your phone. If you have questions on the virtual program's technical issues, please contact Brian Plancher through email here. All right. So we have a very exciting conference program for you. We have 74 papers. And we also, so 5 of them will be virtual, 69 of them are in person. And I am really thrilled that so many of you are so excited to come back to in-person conferences and actually come and present in person. We also have an exciting panel of keynote talks as well as early career spotlight talks. So we have Raquel Erdison from University of Toronto and Wabi.ai, John Rogers from Northwestern University, Henny Edmoni from Carnegie Mellon University as our first early career speaker, and Jens Kover at TU Delft. A couple of bits of announcements. I'm going to steal some of Matej's thunder here, but we have a Thursday lunch tour of Columbia Robotics labs. For those of you who are interested in taking a tour with those labs, please sign up at the registration desk. We have a limited number of slots available, but lunch will be provided during this tour. It is first come, first served though, so please, after the coffee breaks, please feel free to go to the registration desk and sign up. I would like to give a big thanks to all of the sponsors for RSS. We had a number of sponsors, really excited to also see you all in person. They are, the Patreon level sponsors are Amazon Robotics, Dexterity, Raytheon Technologies, and Toyota Research Institute. So a big shout out to you guys. Let's give them all a round of applause. We also have our sponsor level sponsors, which are Mitsubishi Electric, Zoox, and Lockheed Martin. And I guess everyone is so thrilled to be sponsoring things that we only had one small business sponsor. These are at a lower level, but everyone wanted to really chip in and be generous this year. So our last sponsor is Intrinsic. So. Thank you to all of them, and you'll find some of these sponsors will have tables outside where we will have our coffee breaks and poster sessions. Okay, so today's program is going to be, as shown here, as follows. We'll have a session of long talks. We'll have spotlight talks. These short talks will come up next. We'll have our first keynote by Raquel Erdison. After that, we'll have a lunch break, long talks, Henny Edmoni with her early career spotlight, another set of spotlight talks, and then a poster session, which will just be outside over to the, well, my right of the conference, your left. Afterwards, we'll have a welcome reception, which will be back in this conference center with food and drink served. A couple of notes for presenters. Please come up near the beginning of your session so that you can introduce yourself to your session chair. They know that you're actually here. Also for those of you who are setting up posters, you will set up your posters out in the hallway after the coffee break. We do have RSS Pioneers. By the way, for those of you who don't know, RSS Pioneers is an RSS affiliated event which has some of our youngest, our bright young minds that in robotics come together and share their experiences with the robotics community and the kind of academic field. So they are going to have their posters up in the early coffee break sessions. Then they will take their posters down, and then those of you who have main conference posters will then set up, and then you can leave those there through lunch and so on. So another thing about your presentations, for those of you doing short talk presentations, you should please come up here to the front row. This will be the kind of speakers area over here. You'll come up one by one onto your stage. Onto the stage, we'll play your video, and then you'll go ahead and sit down. Please then sit down until the end of your group. We have 4 or 5 sessions per papers per group. Then those 4 or 5 speakers will then come on stage, and then you'll have a group Q&A session. All right. If you have any questions about this procedure, please come and find me during a break. And after the first couple of sessions, hopefully we'll all get the drill. Okay. Mate, I'd like to introduce our local arrangements chair, Mate Chokarli, who will talk to you a bit about kind of last-minute information.
All right, good morning. Welcome to Columbia University's campus. Welcome to New York. We're super happy to have you here today. So just a couple of quick notes. Chris already hit all the key points. You all got an email this morning with a bunch of administrative things, T-shirts and QR codes for the banquet and all of those things. Please read that email carefully because it has important information. In addition to that, there's a couple of things I can mention. So first of all, we do take the mask policy very seriously. So please, when you're in here, unless you're actively taking a sip, please wear the mask and wear it properly. I will come and look at you if you don't, and if you still don't, then I'm going to get Chris, and you don't want that happening. So please take the mask seriously. We have plenty of space. Also, if you look behind you and up there, you see that beautiful VIP section? That's actually open for everybody, okay? So to get there, to get to the balcony, there's an elevator or a set of stairs, kind of at that corner, outside the auditorium in that corner. Take the elevator to the 2nd floor, and then immediately you'll find the entrance to the balcony. So please use the balcony. In total, we have about 1,100 seats, and we should have at most 550, 600 people in the room. So there's place to spread out. Especially right now, there's nobody at the balcony, so if you really are, from a pandemic perspective, you want your space, go to the balcony, and right now you have it all to yourself. Okay, what else? For the banquet tomorrow, the 2 things that I'm going to be stressing again and again. Your QR code on the back of your badge is your ticket to board the cruise. It's a yacht, a boat cruise. If you don't have the badge with the QR code, you won't be able to get on it. So please be sure you have your badge. Anybody who registered before Monday 10 a.m. should have a QR code. If you registered before Monday 10 a.m. and for some reason you don't, come see us at the registration desk. Then I'm going to say this today and again tomorrow. Boarding is at 6:30, the boat leaves at 7. And it's a boat. Once it's gone, it's gone. There's no more getting back on. So make sure you get there on time. For the banquet, for the boat cruise, we have a small number of additional tickets available. Some of you have been emailing us the last couple of days asking if you can bring one more person to the banquet, and I've been saying no so far, but it turns out that we can. So Florian, our registration chair, who by the way has done an incredible job shouldering all the registration load for this conference, he's made available a number of registration tickets for the banquet through the same RSS feed loop registration procedure you went through to register for the conference. Okay? We don't have that many of them. They cost $150, So first come, first serve. If we get more available, we'll open up more of those. But now is the time to go get them. Then also for the lab tours on Thursday, registration is actually also going to be through the same procedure. So go to the RSS website, click register. It'll take you to the feed loop website, and that's where you can sign up for lab tours during lunch break on Thursday. And we will have lunch for lab tour attendees, and you're going to see Shuran's lab, Hod Lipson, Sunil Agrawal's lab, and my own lab. So that's what's going to be happening on Thursday. Okay, for lunch, just go out on Broadway, make a left. This general area, 116th to 110th, has plenty of restaurants, and there's many more. Just check the email that you got this morning. And other than that, you know, enjoy the conference and enjoy the city. Welcome.
Okay, so the chair of our first session is Christopher Heckman from the University of Colorado.
All right, thank you for coming to the first session, making it out here, even though I'm sure many of you had a good night last night. So the first talk today is going to be ACID, Action Conditional Implicit Visual Dynamics for Deformable Object Manipulation. You can come on up and set up. It's going to be presented by Zhenyu Jiang.
Can I switch?
You're on.
Yeah, great. Hopefully it should work.
Do you have audio?
No, I don't.
Do you have audio?
No. Oh, great. Okay. So, hi everyone. I'm Zhenyu Jiang from UT Austin. I'm glad to present our work, ACID, Action Conditional Implicit Visual Dynamics for Deformable Object Manipulation. This is a joint work with collaborators from Stanford, NVIDIA, and Caltech. From playing with plush toys to making pizza dough, deformable objects are prevalent in many daily activities. Perceiving these objects and modeling their dynamics play an integral role in building autonomous robots to interact with these soft objects. Decades of robotic research have developed algorithms for manipulating non-rigid objects. Such methods have shown success in deformable linear objects, cloth and fabric, and some simple primitive 3D shapes. However, modeling general volumetric deformable objects is still beyond reach. Two major challenges of modeling realistic volumetric deformable objects are partial observability and the complex nonlinear dynamics. Deformation can induce severe self-occlusion and make certain parts invisible. In addition, the complex nonlinear dynamics in the infinite configuration space of these deformable objects make the problem even harder. In this project, we study the goal-conditioned volumetric deformable manipulation. Given a start and a goal state observation of a deformable object, we learn a visual dynamics model. With the learned visual dynamics model, we use a model-based control to roll out multiple actions that manipulate the object into the goal state. To tackle the challenges of partial observability and nonlinear dynamics, we introduce ACID, Action Conditional Implicit Dynamics. ACID takes as input the RGBD observation and the action and predicts geometry and dynamics of the object. It reconstructs 3D shape from partial view and predicts action conditional forward dynamics. The key idea of ACID is using neural-implicit representations to jointly represent the geometry and dynamics. Neural-implicit representations are mappings from a 3D coordinate to quantities at the coordinate. It serves as a unified representation for geometry and dynamics. It's continuous and memory efficient, and it can be end-to-end trainable with multiple supervisions. We use neural-implicit representations for occupancy, correspondence, and flow fields. Occupancy field is a mapping from a 3D coordinate to the occupancy value, whether the point is occupied by the object. It encodes the geometry in the neural-implicit representation. We encode the dynamics in the correspondence field and the flow field. The correspondence field contains the local feature descriptor. It is useful when comparing the predicted deformed shape and the goal object. The flow field contains the per point flow vector, which describes the deformation. Our model, ACID, predicts occupancy field and correspondence field from RGBD observation. ACID also predicts the action conditional flow field. We represent the action as a 3D grasp point and a 3D release point. We introduce our occupancy and correspondence prediction here. We first back project the RGBD observation into RGB point cloud. Then we encode and project the point cloud into 2D feature planes. To enhance fine-grained reasoning, we use local implicit representations. Given an arbitrary 3D location, we use bilinear interpolation to query local feature at this location. Our decoder predicts occupancy score and per point feature, given the 3D location and the local feature. The occupancy decoder predicts the occupancy field, and the correspondence decoder predicts the correspondence field. We can supervise the occupancy decoder with the ground truth occupancy. To train the correspondence decoder, we need to specify the correspondence across frames. The object is under deformation across frames, so we need deformation invariant metric to determine if a pair of points are corresponded. We employ geodesic distance, the shortest distance between 2 points on surface. For example, the purple pair of points are not corresponded, so the geodesic distance between them is large, although the Euclidean distance is small. The geodesic distance between the green pair of points is small, and these 2 points are corresponded. So we use the green pair as positive pair and the purple pair as negative pair. We use contrastive loss to pull the point features of positive pairs close and push away the point features of negative pairs. With geodesic-based contrastive loss, our model can predict deformation-consistent point features to establish correspondence. Then I'll introduce our dynamics prediction branch. As presented above, we extract 2D feature planes for occupancy and correspondence field prediction. To predict dynamics from single observation, we use action as an extra input. We combine the back-projected point cloud with the action parameters and use the dynamic encoders to project and encode them into another set of 2D feature planes. Conditioning on both sets of feature planes, our flow decoder predicts the action conditional flow field. In conclusion, our model ACID takes as input an RGBD observation and the action represented as a grasp point and a release point, and simultaneously predicts occupancy field, correspondence field, and the action conditional flow field. To generate training data and evaluate our method, we develop a new framework, PlushSim, for volumetric deformable object manipulation. PlushSim is a simulation framework with GPU-accelerated FEM simulation and real-time ray tracing. It provides realistic dynamics modeling and observations. We generate our dataset with PlushSim, we randomize lighting and scene layout and manipulation actions, and altogether, we get over 17,000 of manipulation trajectories. We split the trajectories into train and test set by objects, so we train and test ACID on different objects. We apply model-based manipulation with ACID as a visual dynamics model. We sample action sequences with ACID's occupancy field. And given the action, we use flow field to predict the object shape after deformation and compute the distance between the predicted shape and the target shape with the correspondence field. And we select the best action based on the distance. We quantitatively evaluate the goal condition manipulation performance of ACID and other baselines. First, we evaluate the pixel flow, which models the visual dynamics in 2D pixel space. Pixel flow predicts incorrect flow direction and shows very poor manipulation performance. It indicates that modeling deformable object dynamics requires reasoning over complete 3D object shape. We also evaluate voxel flow, a voxel-based action conditional visual dynamics model. The voxel representation is discrete and gives noisy and inconsistent flow prediction. This suggests the need of a continuous representation when modeling deformable objects and their dynamics. Benefit from the continuous and compact neural implicit representations, ACID can predict consistent and smooth action conditional flow. In addition, these results are on unseen test object. ACID can generalize learned visual dynamics to unseen objects. We also conduct a self-ablation where we replace the geodesic-based contrastive loss with the Euclidean-based one. With geodesic-based contrastive learning, ACID can establish more accurate correspondence between the predicted and target objects, which boosts the performance of goal-conditioned manipulation. Here we show the qualitative results of manipulation in simulation. ACID can predict consistent correspondence field across the frames. We also apply ACID to real-world deformable objects. Trained with simulated dynamics, ACID-based model predictive control can generalize to real-world observations and successfully manipulate the object into target configuration. We tried some other deformable objects and configurations, benefited from the randomized training data and multi-step property of the model-based manipulation, as it can generalize to objects with different appearances and configuration and dynamics. In conclusion, we propose ACID, which encodes the geometry and dynamics of deformable objects in structured neural implicit representations. To train ACID, we developed PlushSim, an open-source real-time FEM simulation framework for volumetric deformable manipulation. We deploy ACID both in simulation and on the real robot and show successful